Beneath the endless sweep of the night sky, the Milky Way drifts like a river of frozen light. Each star is a silent witness to billions of years, yet together they form a pattern so perfect it feels intentional. The spiral arms curl with mathematical elegance, the galactic core burns with a steady heartbeat, and the laws that govern it all remain unwavering, as if written into the fabric of reality itself. But what if that fabric is not natural at all? What if every particle, every beam of starlight, every breath you take exists because it was calculated, rendered, and displayed by something far beyond our comprehension? Imagine a galaxy not built from dust and gravity, but from information. A masterpiece of cosmic engineering, running on a machine we cannot see. Somewhere, beyond the limits of our senses, there could be an intelligence observing it all, including you. Tonight, we venture into the boldest idea in modern science, the possibility that our galaxy is not the universe's creation, but its simulation. Step closer and see the code behind the stars. Beneath the vast cathedral of stars, a quiet question stirs in the human mind. What if none of this is real? What if the spiraling arms of the Milky Way, the burning hearts of suns, and even our own thoughts are nothing more than patterns of data running inside an unfathomably complex machine? The idea sounds like a fragment of science fiction, yet it is whispered with equal seriousness in the halls of physics and philosophy. We gaze into the night sky searching for answers, never certain if the stars themselves are watching back as lines of code. Across the fabric of the cosmos, the rules of reality seem suspiciously precise. The laws of physics do not bend or waver. They repeat with flawless regularity, as though written into the source code of existence itself. Every electron obeys the same commands. Every photon follows the same pathways, from the birth of galaxies to the beating of our hearts. And in that unwavering precision, some see not a random universe, but one crafted with the meticulous hand of a programmer. It is here, in the shadow between wonder and suspicion, that the cosmic computer hypothesis takes root. Imagine the Milky Way as nothing more than an intricate simulation, rendered in exquisite detail by a system so vast it defies comprehension. Within it, every star could be a calculated projection, every planet a model, every living being an algorithm running with perfect continuity. If so, then somewhere beyond the limits of our perception, the true reality, the one running the code, might be waiting. To grasp the scale of such a possibility, we must first step outside the boundaries of our everyday senses. Our galaxy is a sprawling city of light, 100,000 light-years across, home to hundreds of billions of stars. Yet to a sufficiently advanced intelligence, this monumental structure could be nothing more than a small data file, a vast but compressed model, updating in real time as its inhabitants observe and interact with it. The Milky Way's spirals, so majestic to our telescopes, could be the visual output of equations running effortlessly on an unimaginable processor. Physics itself begins to take on the character of a programming language. Space and time act as the operating system, particles the individual bits of data, and forces like gravity and electromagnetism as subroutines that shape the unfolding narrative of the cosmos. The constancy of the speed of light, the unchanging strength of the fundamental forces, even the quantum rules that dictate probability, all could be the result of deliberate design choices, optimized for stability and complexity. In this view, reality is not an accident, but a carefully tuned simulation, its variables set to create galaxies, stars, planets, and eventually, observers. The unsettling implication is that our deepest scientific breakthroughs might not reveal the true nature of reality at all, but only the rules of the simulation itself. We could be decoding the laws of physics in the same way a character in a video game learns the limits of their world, never aware of the circuitry, servers, or greater reality beyond. In the vast dark between stars, there could be hints that the cosmos is not a boundless expanse, but a canvas with hidden edges. If this is a simulation, then its hidden mechanics must operate beneath the surface of everything we see. At the smallest scales, quantum physics reveals a jittering sea of probabilities where particles seem to flicker into and out of existence. To some, this quantum graininess is not a mystery of nature, but the pixelation of reality itself, the resolution limit of the simulation's rendering engine. Just as a digital image reveals its pixels under a microscope, the universe might betray its computational grid when examined closely enough. Even stranger is the phenomenon of quantum entanglement, where two particles can influence each other instantly across vast distances, as if distance itself were irrelevant. In a simulated reality, this could be nothing more than the system updating both particles simultaneously in the same memory space. No physical signal needed. Such instantaneous coordination would be trivial for a computational framework, but inexplicable in a purely physical universe bound by the speed of light. Some physicists have even suggested that space-time itself could be a kind of holographic projection, information stored in lower dimensions, woven together to create the illusion of a fully three-dimensional world. If so, then the stars above us and the ground beneath our feet are not things in the ultimate sense, but information rendered into a form our minds can perceive. We would not be moving through the galaxy. We would be moving through data. If we look for the most extreme example of such a possibility, we need only consider the limits of computational power in our own time. Already, humanity has begun crafting entire worlds inside machines, virtual landscapes so convincing that a viewer can forget they are looking at pixels. In laboratories and research centers, physicists run simulations of galaxies evolving over billions of years, all compressed into the span of hours. What for nature would take epochs, our computers can recreate in an afternoon. Scale this up by millions or billions of times, and the boundaries between real and simulated blur almost to nothing. A civilization far older than ours, armed with computational capabilities beyond imagination, could easily create a replica of a galaxy like the Milky Way with perfect fidelity. Every star could burn with the same physics as a real one. Every planet orbit in precise harmony, every heartbeat of every creature modeled in seamless detail. To the inhabitants, nothing would ever appear false. And perhaps the most unsettling thought is this: a simulated galaxy need not exist in its entirety all at once. Like a video game that only renders the terrain the player can see, such a reality could generate only the regions being observed at any given moment. The distant corners of the cosmos, those no telescope has yet glimpsed, might not exist at all until someone looks for them, springing into being the instant they enter our field of view. The idea that reality might only load when observed touches a strange nerve in both physics and philosophy. In quantum mechanics, the act of measurement appears to influence the outcome, particles existing in a cloud of possibilities until they are forced to choose by observation. In a simulated universe, this would not be a mystery, but a feature, an optimization to save processing power, rendering detail only when a conscious observer demands it. Our perception could be the trigger that calls the code into action. This also reframes the vast, silent reaches of space in a haunting way. The dark gulfs between galaxies may not be a barren wilderness at all. They may be unrendered voids, placeholders in the program, awaiting their first spark of inquiry. When astronomers turn their telescopes outward, the system could be quietly filling in the details, like a master painter adding strokes to a canvas only when the audience approaches. The cosmos, in this sense, is not fixed. It is actively being written in response to our curiosity. If true, it means our role in the universe is far stranger than we imagine. We would not merely be explorers of a pre-existing reality, but participants in its ongoing creation. Every question we ask, every observation we make, would literally bring more of the universe into existence, as though the cosmos itself were a story unfolding in real time, with us as both characters and co-authors. If this hypothesis holds even a grain of truth, the scientific implications are staggering. It would mean that our greatest telescopes, our most precise particle accelerators, and our deepest mathematical theories are not revealing the bedrock of existence, but only the architecture of the simulation. Every constant, every equation we uncover could be nothing more than the programming rules, the physics engine, chosen by the creators. In this light, the universal laws might not be universal at all, but specific to this particular simulation, just as the physics of one video game may differ entirely from another. Throughout history, humanity has chased the dream of a theory of everything, a single elegant formula that explains all forces and phenomena. But if our galaxy exists within a simulated framework, then this pursuit may lead not to ultimate truth, but to the edge of the code itself. Beyond that edge, the true reality might operate under rules so alien that even our most brilliant minds could not begin to comprehend them. The limits of science in this view are not set by nature, but by the boundaries of the simulation's design. And yet, this does not diminish the beauty or meaning of our discoveries. On the contrary, it adds another layer of wonder. To be inside a simulated galaxy is still to live within a masterpiece, a work of such vast complexity that it can host life, consciousness, and thought capable of questioning its own nature. If the simulation hypothesis is correct, then every equation we write, every experiment we run, is our way of reading the mind of the Creator, line by line. For humanity, the question then shifts from whether we are in a simulation to why such a simulation would exist. Is our galaxy a scientific experiment, a historical archive, or an art form to be admired by beings beyond our perception? Perhaps it is a training ground, a place where consciousness evolves and learns before moving on to whatever reality lies outside. In this framework, the beauty of the Milky Way, the rise and fall of civilizations, even the tragedies and triumphs of our species, could all serve a purpose written into the simulation's intent. This possibility forces us to confront an unsettling thought. If we are in a simulation, then whoever runs it might have the power to alter or end it at will. The constants of physics could be adjusted, the galaxy's structure reprogrammed, or entire star systems deleted without warning. Our history might have already been edited countless times without us ever knowing. Just as we patch software or reset simulations when they drift off course, the creators could adjust our reality whenever they wish, leaving only the faintest traces for the curious to find. Yet, in another light, this is not a source of fear, but of awe. To exist inside such a construct would mean we are part of something vast and deliberate, an undertaking so complex that it could birth intelligent beings capable of love, curiosity, and wonder. If the galaxy is a simulation, then it is not a cold prison of code, but a cathedral of computation where every photon and heartbeat is part of a design far greater than ourselves. If our galaxy truly is a simulation, then its scale and complexity hint at a computational power beyond anything we can conceive. The processor running it might span dimensions we cannot perceive, drawing energy from sources beyond our universe, or tapping directly into the fabric of reality itself. What to us appears as billions of years of cosmic evolution could be the equivalent of moments in the Creator's frame of reference, a slow, deliberate unfolding for them, an entire epoch for us. Time itself could be just another adjustable variable. Such control would allow for unimaginable feats. Civilizations could be rewound to observe their beginnings, alternate versions of history could be tested, and catastrophic events could be reversed or accelerated at will. The collapse of stars, the formation of black holes, even the birth of galaxies might all be engineered, either to serve the simulation's goals or simply to witness the beauty of cosmic events. The Milky Way might not be the only such construct. It could be one of countless simulated galaxies, each with its own laws, histories, and inhabitants, running in parallel across an infinite computational multiverse. And perhaps, buried somewhere in the code of our reality, there are hidden channels, messages from those who built it, left like signatures in the brushstrokes of a painting. We may not yet have the tools to detect them, but one day, a flicker in the cosmic background radiation or a pattern in the arrangement of galaxies could reveal that we were never alone in this creation, that beyond the visible universe, there is an audience, watching. And so we arrive at the most haunting question of all. If we are a simulation, what happens when it ends? Will the lights of the galaxy fade like the closing of a program, or will we simply awaken to a reality more vast and strange than anything we've ever known? Perhaps death itself is merely the act of logging out, our consciousness slipping free from this rendered space into the realm of the true. In that moment, all the mysteries of existence could dissolve into clarity. Whether this is code or cosmos, the experience is real to us. The warmth of sunlight, the pull of gravity, the ache of loss, the thrill of discovery. These are not less meaningful because they might be simulated. If anything, they are more precious, for they are fleeting, bound by the parameters of a system that will not run forever. Meaning is not diminished by the possibility of design. It is deepened by it, as though every moment were chosen with care. So as you look up tonight at the glittering sprawl of the Milky Way, remember, it may be more than a galaxy. It may be a message, a masterpiece, a test, or a dream. And whether it was born from physics or from code, it holds within it the same invitation to wonder, to explore, to question, because in the end, the greatest truth may not be whether we are real, but that we are. And that, in any universe, is enough.